Every year, an average of 20 typhoons hit the Philippines, 5 of which are destructive. Given this situation, it is essential to have careful preparation before a powerful typhoon strikes. But how do we know when a typhoon is coming? Good day to our research advisor. To the panelists, I am Heather Pasicolan and I would like to greet you all a pleasant day. We will be presenting a study entitled Development and Evaluation of Anemometer System with the use of Arduino technology to measure the wind speed in preparing for tropical storm, with our device named as Typhoon Warning and Monitoring using Anemometer System or the Typhometer. The typhometer is a device that detects the wind speed of a specific location. When it encounters an unusual or higher than normal average wind speed value, it produces an alarm sound to alert the authorities or the people around. Let's now call on Ms. Narido for the conceptual framework.
Thank you, Ms. Pasicolan. Now let's go for conceptual framework. We have input, process, and output. For the input, it contains knowledge, software, hardware requirements, materials, and equipments. For the process, it involves planning, designing, and developing of our prototype. And lastly, our output, which is typhometer. Typhometer means typhoon warning and monitoring using anemometer system. Now let's go to Ms. Pereira for the objectives.
Thank you, Miss Narido. So we set our objectives as a goal we try to achieve. So for our group's objective here is to investigate the accuracy of the typometer in terms of detecting wind speed, portability, and sensor coding. The second was to determine the exterior structure of the typometer in terms of portability, distinguishability, and durability. The third one is to evaluate the convenience of typometer in terms of its size, weight, and durability. For the next slide, may I call on Miss Ibarbia?
Thank you, Ms. Per. For our scope and limitations, our study will only include grade 12 students school year from 2021 to 2022. Students from other schools or countries are not included in the study, and our device is only limited to 70 miles per second of wind speed. Now, may we call on Ms. Ruiz for the significance of the study.
Thank you, Ms. Ivarbia. For the significance of the study, these are the following people who are going to benefit our research. First is the government. The government will provide comprehensive humanitarian help and protection. Second are the farmers. With this device, they will be prepared when they should plant and when they need to harvest. Third are the students. They will be notified early with this device, especially at school. Fourth are the teachers. This device will help teachers stay informed about the weather on a daily basis. And lastly is the community. This is highly beneficial to the community since it keeps them informed about the weather and they will be prepared. That's all for my part.
So let us now call on Ms. Francine Julosio for the synthesis of related literature and studies of our research.
Thank you, Ms. Malupig. And for the synthesis of RRL and RRS, there are various researchers around the world studies that involves wind speed and several types of anemometers which are important to prepare for catastrophic incidents. And according to them, our country is prone in natural calamities. And despite of advancements made by new technologies, they proposed Arduino-based disaster managements to increase the efficiency and efficiency of first responders, thereby extending the role of technology in disaster relief. The cap anemometer remains the most common wind speed sensor because of its balance between accuracy, low cost, and reliability. In a study done by researchers, they found that constructing a weather monitoring system to keep track of the weather is beneficial for the local community. And for the research design, here is Ms. Ibarbia.
Starting our chapter 3 is our research design. This research is in the form of descriptive research, specifically the observation studies. The method will help researchers determine the efficacy of the wind speed sensor device's components, as well as its components and characteristics. This will help us present the advancement and performance of the prototype to its specific application. The figure below is the illustration of the typometer's design. May we call on Ms. Bermundo for the sampling method and sampling size.
Thank you for that, Ms. Barbara. Now for the sampling method, population, sampling size, and participants. Students who are now in grade 12 senior high school in the school year of 2021 and 2022 and taking science, technology, engineering, and mathematics strand are the participants for the study. With a population of 371 STEM grade 12 students, the researchers used stratified sampling method and the sampling size was reduced to 192 respondents. We assume that they should be aware of the effectiveness of an anemometer in measuring wind speed, owing to the accessibility of Arduino technology in storm preparedness. Now, here's Ms. Ferrer to talk about the research instrument.
Thank you, Ms. Manlupig. And for our research instrument, an online survey was conducted via Google Forms since we're still in the middle of pandemic and our respondents was familiar to this type of form. So by answering our survey, the respondents have been requested to test their favored score primarily based on the minds regarding of the device efficiency in measuring the wind speed in preparing for tropical storms. May I call on Ms. Pasicolan for the next slide?
For the statement of the problem, our first question is how can the anemometer system be accurate in terms of detecting wind speed, alarm system, and sensor coding? Second is what is the anemometer system's exterior structure in terms of its portability, distinguishability, and durability? And lastly, what are the characteristics of the anemometer system in terms of its size, weight, and durability?
For the product testing, we conducted 3 trials for every functions of our sensors to our prototype. The anemometer sensor is capable of measuring wind speed. The LCD display is also capable of displaying text or the wind speed status, while the LED bulb turns on its lights and buzzer makes sounds when unusual wind speed is detected. So all of them have passed our trials. Chapter 4.
So for the presentation, interpretation, and analysis of data, this chapter shows the study findings in order to specific problems was described in the statement of the problem. So here we are gathering the data from our survey. Next slide, please. For the accuracy, as you can see, most of them answered strongly agree.
For the exterior structure, most of them also agree. Most of them also answered strongly agree.
For the characteristics, most of them answered strongly agree.
For our table of mean results and interpretation, we have 3 categories: the accuracy, exterior structure, and characteristics. Per categories, we have 3 questions, and all of the mean scores of our question is between 3.26 to 4, which is equivalent to strongly agree. How did we get the mean score? We get the mean score by multiplying the numbers of our data and then get their total, then divide them by 192, which is the total number of our respondents. Next is go to chapter 5.
In the conclusion, due to the natural calamities that happens in our country, us researchers develop a device called Typhometer to use for prevention in calamities such as typhoon. We based our conclusion in the survey, asking the respondents various questions about whether the prototype met the objective that we set for it. By how the respondents answered the survey question, we conclude that typhometer is useful for detecting anomalous wind conditions. Typhometer met the 3 categories of the objective. The sensors attached to the device were working properly and accurately in measuring wind speed. Now here's Miss Bermundo for half of the conclusion.
Thank you, Ms. Ibanez. Now, when it comes to the device external design, participants unanimously agreed that it was sturdy, easy to set up, and portable since it had a distinct structure that defines its overall appearance. Now, the device features of being lightweight and having a suitable size according to the majority of survey respondents make it more accessible and pleasant to use. As an outcome, the researchers arrived in the conclusion that the typhometer may be used to warn people about the impending catastrophic typhoons. Now, here is Miss Ruiz to tackle about our recommendations.
Thank you, Ms. Bermundo. We, the researchers, have made a recommendation for future researchers who will pursue the product. To begin, we recommend a more sturdy corrosion-proof case to make a more durable and long-lasting case for the product. Second, for easier signal recognition, install different colors of LED that correspond to the type of signal. Third, future researchers can improve accessibility and ease of use by including an SMS. Fourth, we recommend purchasing a switch button to make turning on and off the power source much easier while the prototype is not in use. Finally, the Typhometer-related system alerts are installed on a variety of devices, which can be useful for notifying anyone in the household when the wind speed fluctuates rapidly.
Again, we are Group 4 and the room is now open for questions, suggestions, and recommendations. That will be all. Thank you.